On April 18, 1955, Albert Einstein died at Princeton Hospital in New Jersey. Within 7 hours, a pathologist named Thomas Harvey had removed Einstein's brain without the family's permission, placed it in a jar of formaldehyde, and taken it home. For the next 40 years, Harvey kept the brain, sometimes in a cider box under a beer cooler. He sliced it into 240 blocks, mounted them on microscope slides, and occasionally mailed pieces to researchers around the world. It sounds like the behavior of a madman. But what those researchers eventually found changed our understanding of intelligence forever. Einstein's brain was not bigger than average. In fact, it was slightly smaller. But his inferior parietal lobule, the region associated with spatial reasoning and mathematical thought, was 15% wider than normal. His corpus callosum, the bridge connecting the left and right hemispheres, was thicker than expected. And his brain had an unusually high ratio of glial cells to neurons, support cells that enhance neural communication. The question that launched a century of research: was Einstein born this way, or did his brain become this way because of how he used it? The answer, it turns out, is both. And understanding that answer is the key to understanding genius itself. The most persistent myth about genius is that it is innate, a divine gift deposited at birth into a lucky few. This myth is comforting. It lets the rest of us off the hook. If Einstein was simply born different, then our own ordinariness is not our fault. But the research tells a different story. In 1993, psychologist K. Anders Ericsson at Florida State University published one of the most influential studies in the history of expertise research. He studied violinists at the Berlin Academy of Music and found that the best performers had accumulated approximately 10,000 hours of what he called deliberate practice. The good performers had about 8,000 hours. The average ones had about 5,000. The critical finding was not the number. It was that Ericsson could not find a single natural, someone who reached elite performance without extensive practice, and he could not find a single grinder, someone who practiced extensively but failed to improve. A 2014 meta-analysis published in Psychological Science examined 88 studies across music, games, sports, education, and professions. Deliberate practice accounted for about 26% of the variance in games, 21% in music, and 18% in sports. That is significant, but it also means other factors matter. The takeaway: talent is not a myth, but it is not destiny either. Genius emerges from the interaction between predisposition and relentless, structured effort. The question is not whether you are talented, it is whether you are willing to build on whatever raw material you have. Before Ericsson's 10,000-hour finding, cognitive scientist Herbert Simon observed something curious. No one in any field produced world-class work with less than 10 years of intensive preparation. He called it the 10-year rule. Mozart, often cited as the ultimate prodigy, composed his first masterwork, Piano Concerto No. 9, at age 21, after roughly 13 years of intensive training under his father's obsessive instruction. His childhood compositions, while impressive for a child, are not considered masterpieces by musicologists. Srinivasa Ramanujan, the self-taught mathematical genius from India, is often held up as proof that genius can appear from nowhere. But a closer look reveals that Ramanujan spent years in solitary, obsessive study. By the time he wrote his famous letter to G.H. Hardy at Cambridge in 1913, he had filled entire notebooks with thousands of formulas, developed largely in isolation. He did not lack training, he lacked formal training. His practice was intense, self-directed, and consumed his entire life. A 2019 study in Intelligence examined the early developmental histories of 18 individuals identified as geniuses across multiple domains. Every single one showed evidence of prolonged, intense engagement with their domain beginning in childhood or early adolescence. None arrived at breakthrough without an extended apprenticeship period. The practical insight: if you are 3 years into something and feel like you have not achieved mastery, you are not behind schedule. You are on schedule. The timeline for extraordinary achievement is measured in decades, not months. In the 1970s, psychologist Mihaly Csikszentmihalyi began studying what he called optimal experience. He interviewed hundreds of artists, athletes, surgeons, and chess players, asking a simple question: when are you performing at your absolute best? The answer was remarkably consistent. Peak performance occurred in a state of complete absorption, where the challenge perfectly matched the person's skill level, self-consciousness disappeared, and time seemed to distort. Csikszentmihalyi called this flow. What makes flow relevant to genius is that it appears to be the state in which breakthrough thinking occurs. Nikola Tesla described his inventive process in terms that map directly onto flow. He would visualize machines in his mind so completely that he could mentally run them for weeks, detecting wear patterns before a single part was built. He was not daydreaming. He was in a sustained state of deep cognitive absorption. A 2014 study in Frontiers in Psychology used neuroimaging to examine the brain during flow states. The researchers found transient hypofrontality, a temporary reduction in activity in the prefrontal cortex, the brain region responsible for self-monitoring and inner criticism. In flow, the inner critic shuts down. The brain stops evaluating and starts producing. Leonardo da Vinci's notebooks reveal a mind in near constant flow. He would begin sketching a machine, then branch into anatomy, then into fluid dynamics, then into optics, each topic feeding the next in an unbroken chain of curiosity. His genius was not that he was smarter than everyone else. It was that he could sustain deep engagement across an extraordinary range of domains. The takeaway, flow is not a luxury. It is the psychological state in which genius-level work is produced. Protecting your ability to enter flow by eliminating distractions, matching challenge to skill, and pursuing intrinsic motivation is the single most practical thing you can do to increase the quality of your creative output. IQ tests measure convergent thinking, the ability to find the single correct answer. But genius, particularly creative genius, depends on something different: divergent thinking. The ability to generate multiple novel solutions to an open-ended problem. In the 1960s, psychologist J.P. Guilford developed tests for divergent thinking. One classic example: how many uses can you think of for a brick? Average respondents might list 5 to 10. Highly creative individuals routinely generate 30 or more, including uses that are surprising, abstract, or cross-domain. A 2017 study in thinking skills and creativity used neuroimaging to examine divergent thinking and found that it activates a network spanning both hemispheres, including the default mode network associated with mind wandering and imagination, and the executive control network associated with focused reasoning. Creative genius, the study suggested, requires the ability to toggle fluidly between these two networks, to dream and then to evaluate, to wander and then to evaluate, to wander and then to focus. Einstein himself described his thinking process as combinatory play, taking ideas from unrelated domains and combining them in novel ways. His theory of general relativity emerged in part from a thought experiment about riding a beam of light, an act of imagination, not calculation. Ramanujan told colleagues that mathematical formulas appeared to him in dreams, delivered by the goddess Namagiri. Whether interpreted spiritually or neurologically, what he was describing is the default mode network at work during sleep, combining, recombining, and surfacing novel patterns. The practical insight: if you only think in straight lines, you will only arrive at predictable destinations. Schedule time for unstructured thought. Let your mind wander. The brain's most creative work happens not when you are grinding, but when you are drifting, and then snapping back to evaluate what surfaced. The most important discovery in modern neuroscience for the question of genius is neuroplasticity, the brain's ability to physically reorganize itself in response to experience. Einstein's enlarged parietal lobule was not necessarily a birth condition. London taxi drivers who spend years memorizing the city's complex street map develop measurably larger hippocampi, the brain region responsible for spatial navigation. Professional musicians have thicker motor cortices. Bilingual speakers have denser gray matter in language regions. A 2020 review in Nature Reviews Neuroscience summarized 3 decades of plasticity research and concluded that sustained, intensive engagement with any complex task physically reshapes the brain's architecture. New synapses form, existing pathways myelinate, wrapping in fatty insulation that speeds signal transmission. Unused connections are pruned. The brain you have today is not the brain you were born with. It is the brain your experiences built. This means genius is, in part, a construction project. Tesla's ability to visualize machines in 3 dimensions was not magic. It was the product of decades of practice that physically rewired his visual processing systems. Da Vinci's ability to connect anatomy to engineering was the result of a brain that had been deliberately cross-trained across disciplines. The takeaway is both humbling and empowering. You cannot become Einstein by wishing. But you can, through sustained, deliberate effort, build a brain that is measurably different from the one you started with. The ceiling may vary from person to person, but the direction of growth is available to everyone. There is one final trait that connects nearly every genius in the historical record, and it is not intelligence, creativity, or practice. It is obsession. Darwin spent 8 years studying barnacles. Newton reportedly forgot to eat for days while working. Marie Curie carried radioactive isotopes in her pockets and kept them in her desk drawer, eventually dying from their effects. Ramanujan worked on mathematics until his body failed. A 2016 study in the Journal of Creative Behavior examined biographical data from 200 eminent creators and found that the strongest predictor of lifetime creative achievement was not IQ, not education and not socioeconomic background. It was what the researchers called rage to master, an intrinsic, almost compulsive drive to engage with a domain. This is not the same as discipline. Discipline implies forcing yourself to work. Obsession means you cannot stop. The genius does not sit down to practice because a schedule says so. The genius sits down because the problem will not leave them alone. And here is the uncomfortable truth: obsession is not always healthy. Many geniuses were deeply unhappy, socially isolated, or physically self-destructive. The same trait that produced extraordinary work also consumed the rest of their lives. The practical insight: you do not need to destroy yourself to do great work. But you do need to find the thing that pulls you forward without external reward, the thing you would do even if no one was watching, even if no one cared. That pull is the seed of everything. Genius is not a category of person. It is a category of commitment, sustained, structured, and deep enough to reshape the brain that makes it possible. Einstein's brain was different, but it was different because of how he used it. And that is the human code, not written in your genes, but built, synapse by synapse, by the choices you make about where to aim your attention.